Hey everybody, I thought it'd be worth our time to quickly go through the answer key for assignment 1 getting started so you can get some feedback on how you did. Again, I will be extremely generous in the grading. Even if you miss most of these, you're probably still going to score it pretty well. So don't worry too much about it, but this is a good chance to review some things and just see how you did. So again, make sure I have your information from your peers. You will want to connect with them so you can compare answers, especially in the labs, so that way you can check your work. And I also want feedback on SPSS, making sure you have your copy. If you don't panic. I'm happy to personally call you, walk you through steps, see what any issues you are having, create tickets with IT, whatever we need to do. Let's make sure you have your tool that you need. So please let me know how I can help. All right, what do you remember? First, what does ANOVA stand for? Analysis of variance. I get some funny acronyms when people don't know. It's kind of funny. Specifically, ANOVAs compare the means of different groups and test for statistical significance between them. So let's say we wanted to test the hypothesis that we think women serve less time in the military than men do. But we don't know for sure, so basically we have a variable called gender. We have another variable called time served in the military in years. And we could actually run an ANOVA test and see if there is an actual difference between the average length of time that women serve versus men, and get the answer to that question. Or if there really is no difference, maybe it's the same. So ANOVAs are kind of fun. We'll definitely run those in class. Now some questions. A small group of football players weighed the following. I gave you some weights right here. What is the player's average or mean weight? 230. Okay, you should be able to calculate an average or a mean. Take all the numbers, divide by the total number of numbers, and you got the average or mean. I think we all know how to do means. It's okay, you can be honest if you had to break out your calculator. That's fine, I would have done it too. Okay, a class experiment with nursing students included measuring blood pressures on one another. The results for the systolic blood pressure were these amounts. What is the mode blood pressure in the students? It is 104. Okay, it's the most frequently occurring observation. So 104, 104, 104, 104. You see them all over here. So it's the one we see the most. That's what the mode is. The mode tells us all kinds of stuff about the data. More on that later. Okay, you are conducting a study of people's attitudes toward gun control. The ages of your sample are 10, 15, 18, 20, 25, 30, 50. What is the range of ages in your sample? Bing! 40. The way to calculate the range, take the highest value, subtract the lowest value. 50 minus 10 gives you 40. I don't love the range because it doesn't really tell me what the max and min are. I could get a 40 by lots of combinations of numbers, a 60 and a 20, a 70 and a 30. So I actually just prefer to give the min and the max. I think it's more useful to people reading my results. A misguided professor, you never have any of those, decided to report test results in z-scores to his students. Many students were horrified to learn their scores were near zero. Z-scores near zero actually mean that the students' test results were average. So a z-score is just what we call standardizing the data. Sometimes the way things are measured are not uniform, and we need all the different units they're measured in to conform together so we can analyze them. And so that's what we use z-scores for. We actually standardize things so that we can measure them better and get meaningful results. When you approach a zero, when you've standardized your data, you're actually getting closer to the mean or the average. We're not going to do a lot of z-scores, so you don't have to think too much about that. Please do not put a z in front of any variable that you end up working on in class, because what SPSS does when it calculates z-scores is it puts a z in front of the variable. So if I see a z in front of your variable, I'm going to think you z-scored your data when maybe you didn't. Some people do it just to make their variable appear at the bottom of a list so they can sort it alphabetically. Good thought, not a good way to do it. So avoid that mistake. Name the scale of measurement for the variable gender. Male, female. This is a nominal scale variable, or a level of measurement nominal. Nominal meaning name or a category. So it actually matters very much how we measure data because it gives us different statistical power. I'm going to bang this into your heads every week. Nominal, ordinal, interval, ratio. Because if you know how something is measured and the scale of measurement, you're going to know what to run, period. If you know how your data are distributed and the level of measurement, you will always know what statistic to run. It's very, very simple. So if you know this really well, you will never, ever be intimidated by statistics again. Okay, if you had a distribution with a mean of 25, a standard deviation of 5, what percentage of your observations should fall between 20 and 30? Or basically, one standard deviation away from the mean. 25 plus or minus 5. You could also have drawn this. There's the mean, 25, 5 below, 5 above, will always give you, in a normal distribution, about 68% of the observations. If we went 2 standard deviations out, we'd get 95%. 3 standard deviations, 99%. What the heck is a standard deviation? It's how much variation there is around the mean. That's it. How far do I have to go to stay close to all the other ones? So think of it in terms of leaves. What if I sent everyone in class to go out to the UF campus, pick up a leaf, bring it back in class? We write all the measurements of our leaves down in centimeters. We stick it in a spreadsheet. We analyze it. We find out what the average leaf length is. All of us would be somewhere close to the average. Some people a little higher, some a little lower. But we'd all be somewhere near that mean. And to know how far we have to go away from that mean to get most people's leaf lengths is the standard deviation. So maybe the average leaf length was 25 centimeters. To get most of the little bit bigger ones and a little bit smaller ones, we'd have to go a little bit further out, 5 centimeters up, 5 centimeters down, and we'd get most of those leaf lengths. If we wanted even more, we'd have to go 10 out, this way, and we'd get 95. Even more, we'd have to go 15 out, and we'd have nearly everybody's leaf lengths in there, maybe except for 1 or 2. There's a lot of great normal distribution in nature. A lot of symmetry, great predictive power. We love normal curves because prediction gets really easy when you have this beautiful curve because of that symmetry. Okay, name the type of scale of measurement, or again we call it level of measurement for the variable weight. It is, bing, a ratio scale. Ratio meaning it's numerical, but it must have a true 0 point. Weight has a true 0 point. You can't be negative pounds. I've tried. You can't be negative. You can only be positive. So interval is also a numerical kind of measurement, but it doesn't matter if you're above or below 0. You can be positive, negative. Ratio, it does. You can't be negative. You always have to be 0 or above it. So weight would be ratio. Again, gives us lots of statistical power when we know how stuff is measured. You're conducting a study about birth order. Which scale of measurement would you use? Bing! Ordinal. So in a birth order study, we might know who's oldest or youngest, middle child, who was born first or last, or the order you're born in, hence the word ordinal. So ordinal variables are variables that we can rank order with first, last, highest, lowest, knowing that something happened here and then this happened, and give it some greater or lesser value. We can't quantify it because we don't have people's birth years, we don't know how their ages work, but we just know you're older and he's younger. Okay, so we can rank order it, gives us a little more information than just a category. We know who's older and younger, but we can't do much more than that. So it's an ordinal scale variable. A group of student pilots practiced precision landings and was given percentile ranks to compare with each other. If a student had percentile rank of 80, this would mean 80% of the student pilots were at or below that score. So you see percentile ranks with things like SAT and ACT scores. It basically is a statistic that lets you compare your performance versus others' performance, how many people are at that place. Name the type of scale of measurement for the variable of temperature in degrees Celsius. Can the temperature go below 0? Yes, absolutely. That's where I moved from. It got to negative 26 degrees. I don't even want to think about that. So yeah, that is interval. So you can go positive, you can go negative. It's something we can quantify into a number. We love interval variables. They give us lots of statistical power. We use them for certain techniques. We'll talk more about that later. Okay, rounding out the end. In your own words, describe what a chi-square is. Here's the wordy, textbooky version, but also some of my own thoughts. Assesses what we call goodness of fit. How these two variables fit together, whether they have any kind of association with each other. But it's goodness of fit of observations, whether they differ from a hypothesized observation. Also, it's a test of independence, for example, pairing variables in a 2x2 contingency table, checking whether or not they occur together or are different from one another. You can even say it is the observed subtracted from the expected, then squared, and finally divided by theoretical frequency, what we think should be happening. Okay, so we want to see if these two things tend to occur together. That's it. Maybe we think knowing your racial group and how often you attend church would help us see if those two things have anything to do with each other. Maybe we have a prediction that we think certain racial groups go more or less often to church. We don't know. We want to test it. Chi-square would let us do that. Chi-squares test nominal and ordinal variables. It's kind of fun. What does it mean if something is statistically significant? This one's a toughie. Basically, it means an observed pattern or a result would likely continue to exist even if we took another sample from the entire population, tested it again, we'd get the same result. We can be confident that the same result exists in the entire population with very little doubt, usually less than 5% doubt that it is not actually true. So we can say that we are 95% confident that this is a true result. Okay, so we like things that are statistically significant because we feel pretty good about saying this is real, it's true, it happens, and it's likely to happen even if we did it again and again. What is an outlier? It's an observation that's numerically different from the rest of the data or falls well outside the majority of observations in a variable. For example, if we were to take a measure of income, which would be called an interval variable because it's a quantity, and we wrote down each other's incomes, we get all the incomes lined up, and then in walks Bill Gates. He would be an outlier because his income would be so far away from the rest of ours that he would tug at the data and kind of skew it. So that goes into the next question. Why do outliers matter? They cause measurement errors. You can risk kurtosis, fancy word for skewness, or a wider uneven distribution of the observations that don't cluster around the mean. Can you imagine what the average income would be if he was in the data? That would be bad. Outliers also distort the true mean of a variable. We just talked about that. What are the measures of central tendency? The 3 M's, mean, median, mode. The statistics that tend to be exact or similar enough numerically, which demonstrates normally distributed data. So if you're trying to figure out if you have normal data, just look at the mean, median, and mode of that variable. If they're all really close to each other, about the same, you can be confident you have normal data. If they're not, you probably have not normal data, a little skewed data, but that's why we care about measures of central tendency. They're all going to cluster around each other. Okay, in SPSS, a scale variable is also known as a numerical variable. Okay, so we use a lot of language interchangeably, statistical language, mathematical language, and even just practical science researchy language. So you're going to hear some of these back and forth, and sometimes it's a lot to keep track of. But scale, numerical, interval, ratio, they're all really the same thing. They're some quantity. Okay, they're just called different things in the software program than sometimes we use statistically. But you'll hear both, and I didn't want you to get confused. Ooh, here's a big one. What is the difference between quantitative research and qualitative? Quantitative, systematic, large-scale empirical investigation of social phenomena using statistics, mathematics, counts, and large quantities of data. It yields broad, high-level applications of the results, generalizable, great for theory testing. We often use experiments and surveys and quantitative approaches, asking the what, where, when. Qualitative is in-depth, specific investigation of social phenomena, asking the why and how, using focus samples, content analysis, participant observation, focus groups, ethnography, interviews, to yield rich data about behavior. You can't generalize it, but often theory can emerge in the patterns that are found here. So again, if you have something in the ballpark, similar, maybe stuff you pulled from the lecture, you'll be okay. You're getting after it, and that's good. All right, now we have the truth questions. Okay, so we're actually going to collect the data on these questions, and we're going to do some statistics. So I'm going to see what the answers were here, and we're going to actually tabulate some statistics. I'm worried about my performance, my biggest fear, and we're going to see what the data yield about the class and analyze you for a change. Again, don't worry, I promise I will not reveal anything personal or private. I will keep that private. But that's basically your answer key. So hopefully you learned something, remembered a few things, and have some reassurance that everything's going to be fine. So I'll see you guys next time in more statistics review. Bye.